Okay, so the basics of a rasterizer are basically how at least how mine works, which is the first version, kind of. It's the one that I didn't put on the GPU. I might make a video on that one, but which I'll have the link to the GitHub in the description if you want to check it out. But basically, how my rasterizer works is every polygon is represented by 9 values, which are the X, Y, and Z values of each polygon, or each vertice on the triangle. So here's A, B, and C. So the first step of my rasterizer is it calculates the AABB, or the axis aligned bounding box of the triangle, which basically it loops through every vertice, and it finds the, pretend this lines up, and it what it does is this is my AABB. What it does is it checks the highest Y, so the max Y, and the lowest Y, and the lowest X, and the highest X, and it just checks, is this pixel, let's say this is the pixel where my cursor is this pixel touching, or is it inside this square? And if no, then you skip the check for it, because skipping the check is faster than doing the check. So next what you do is, if it is inside, so if my point is inside here, then it draws a line from itself off to infinity, doesn't matter what direction, and it checks for any hits, any intersections. So like here and here are intersections, and it's kind of hard to believe. I don't know, it feels really wrong, like it feels too simple to be true. But if you have a polygon, a closed polygon, and you draw a line off from a point to infinity, and you count up the number of intersections, if it's an odd number, that means it's inside of it, and if it's an even number, it means it's outside of it. So see, I have 1, 2, which is an even number, so it's outside, but if I have this one, it's only 1. So it is inside of it. And also, this also works for polygons like this, where it's like this. Then see 1, 2, 3, 4, 5, 6, 7, 8, which is even, or let's say this way, 1, 2, 3, which is odd. So it's just kind of interesting. But basically, for every pixel, it does this check for each pixel, and if it's inside, then it tells the pixel that it needs to draw it this color. So the next part is called the Z buffer. So remember how I have a Z value here, but I'm not using it in this thing because I only have the X and Y. X and Y. So why would I need the Z? So let's say you have a polygon here, and then you have one behind it that like cuts through it like this. How do I do that? How do I show, or how do I figure this out? Because let's say they're just in an order, in a list. If this one comes first, then this one. If it comes first, then it draws it, and then this one comes next, then it just draws it over like this. So how do I do this? Which is where you get the Z buffer. And so what you do is, if you know anything about UV mapping, it's kind of similar to that, where you get your point, let's say the pixel's here, and then you find out basically the distance from each one of these, and then you assign them weights. So this would be weight 0, weight 1, and weight 2. And what you do is, it doesn't matter how skewed the triangle is, like this, even if it's like this, it'll always work just because of how the math works out. So what you do is, to get the z value, z equals, I'll do z hat. Z hat is equal to z0 times weight 0 plus z1 times weight 1 ECT. So ETC. So then you can just find the z value. And so let's say this one is like -1z, this one is 0, and this one is 1. So what eventually happens is you have a gradient from this, from -1. So let's say you had these pixels. This line right here is from -1 to 0. This line here is 0 to 1, and this one's -1 to 1. And so what you could also do is imagine you have this. So this one is, as I said, 1 to 0. This one is 1 to -1, but this one is 1 to -0.5. And so kind of, this isn't how it works, but you can imagine this. It kind of works like this, how if you had an infinitely dense amount of lines, that's how it would kind of, it's a gradient. I was just getting other ways to explain it out, but it just makes a gradient. That's basically it. Oh yeah, so to use the z buffer, you just check, do the axis line bounding box, and then you check if it's inside the polygon, then you check its z value, and if the z value in the z buffer at this location is basically, if it's closer than what's already in there, then just draw it. If it's farther, then don't draw it because it's being included. And if there's nothing in there, then just put itself in there, and that's basically it. So it's pretty simple. I recommend doing it. It's fun to learn this kind of stuff. It's just good to know how things work, I guess. But there's stuff that I'm going to implement in my GPU accelerated one, which is what the GitHub is, which I'm working on. And I'm gonna add stuff like, well, I guess textures. I need textures, and I'm also adding objects right now. It's really tricky, and the code that I haven't committed yet is horrible, or haven't pushed to the GitHub is horrible. So I think I might push working code and then fix it later, which basically means I'm never gonna fix it. But it works all right now. I don't know if I'll use it as like B-roll for this video, or maybe I'll put it in the corner, but I'll definitely upload it separately so you can watch it's just the full video of me programming the thing, with some parts edited out because it was just like, if I just kind of sat there thinking, I edited it out because why would you want to look at a blank, basically an unmoving screen for like 3 minutes? It might also be sped up too, because YouTube takes forever to upload things. Oh, and also, I thought this was a YouTube issue. I just reinstalled Linux, and I forgot to update my OBS settings, so I've been recording in, like, 1200 by 400 this entire time. So, I'm sorry for that. I am now recording in 1080p. So, yeah, 1080p is good. It's better than, it is better than 720p. So yeah, in the description I'll put a link to the B-roll or whatever, and then I'll put a link to the GitHub. If you're interested in helping out or like committing stuff to it, then definitely contact me if you're interested in that. Yeah, that's about it.